question is, how close to 2 does x need to be for to be between? Alright, so if x is really close to 2, this is close to 5. So let's go 1 unit above and 1 unit below. So for this equation to be between 4 and 6. Alright, we can get this purely with algebra. So let's think about what this graph looks like. Well, y equals 2x plus 1 is this. And how close does x need to be to 2? Well, here's 2. And we see that around 2 we're close to 5. And we want our function, this straight line, to be between 4 and 6. So how close to 2 does x need to be? Well, let's see. We need to know now what values of x bring us to 4 and what values of x bring us to 6. So simply solve. What value of x makes our function 4? That would be 3 halves. So this has an x coordinate of 3 halves. What value of x will bring our function to 6? That would be 5 halves. So it looks to me like we can either go half a unit to the right of 2 or half a unit to the left of 2. So the answer, how close does x need to be to 2? The answer is 1/2 of a unit. Alright, so that's the question phrased in simple algebraic terms. Now let's ask the same question, but in terms of calculus. So in terms of calculus, we have the limit as x approaches 2 of our function equals to 5. And what we're going to do is we're going to find a delta for epsilon equals 1. This is the exact same question that we just answered. To find a delta, what I do is I start by setting up the 2 inequalities that we see in the definition. So the first inequality and the second less than epsilon. I'm going to put epsilon equals 1 in at the end, so right now I'm just going to stick with the Greek letter. Okay, so once we set up our 2 inequalities, you need to factor your f of x minus L. You should always be able to factor an x minus c out of your f of x minus L. So start simplifying this. Okay, so we have factored the x minus c from the f of x minus L. Then we use an argument. So 2 times the left side of this inequality, so 2 times absolute x minus 2, should be less than 2 times the right side. So this should be less than 2 deltas. We would like to have our f of x minus L less than epsilon. Right now we're 100% sure it's less than 2 deltas. So if we were to simply set our 2 deltas equal to epsilon and solve, we would get delta equals epsilon over 2. And if epsilon is 1, that would be a delta equals to 1/2. So we get the exact same answer either way. So all this is asking when it's asking you to find a delta is how close does x need to be to c to keep your function epsilon close to L. Yes?
Did you just multiply, like on that step after you wrote the equality, everything by 2?
Essentially, yes. I multiplied both sides of this inequality by 2. So 2 times this would produce this. And that should be less than 2 times delta. And now we're certain f of x minus L is less than 2 deltas. We want it to be less than epsilon, so we simply set our 2 deltas to epsilon and solve.